Welcome to the video for section 7.2, and section 7.2 is going to be about finding complex solutions of polynomial equations. As I said in class, these problems are going to look very similar to the ones we've already been working on. The only difference now is that the solutions that we find may not all be real numbers, they may not be fractions, we might start dealing with some irrationals, we might start dealing with some complex numbers. Okay, so we go back to the fundamental theorem of algebra. If you remember what we talked about with that, we said that degree n polynomials have n complex roots. Okay, remember what we talked about earlier in the chapter. A complex number can be a nice number like 3 or a fraction like -1/4, but it could also be something like 2 plus I. And you can't graph the number 2 plus I on a graph. So that means for some equations, not every x-intercept is going to be visible. So that means we may have to deal with I and use the quadratic formula to solve some of these equations, and you'll see some of those here in the notes. Okay, let's start with a quick little review of some double roots. I know we talked about those in the last section. But we want to find all the roots of x cubed plus 7x squared. And for this one, if I set x cubed plus 7x squared equals to 0, I don't have to use synthetic division. Because notice each term has two x's in common. So I can factor those out and then be left with x plus 7. And once I have two factors, remember, if two things multiply and equal 0, that means one of them has to be 0. So that enables me to set each factor equal to 0 and solve. If I subtract 7 from both sides of the x plus 7, I get x equals -7. If I take the square root of both sides of x squared equals 0, well, x is going to equal 0. Now you might be thinking, well, what about the plus or minus? Well, 0 doesn't have a sign. 0 is just 0. Then you also might be thinking, well, I only have two numbers. How come there's 3 roots? Well, that's because this 0 is a double root. And we get that from the x squared. There's supposed to be two answers to that equation, but only one number showed up. So for this equation, the roots are 0 and 7, but 0 is a double root. So technically, the 3 roots are 0, 0 again, and 7. Now let's look at the next example. We want to find the roots of x cubed plus 8. Now, this should look familiar to you. This is a pattern that we've covered before. This is a sum of two cubes. Remember, if we have a sum of two perfect cubes, we can factor them using the a plus b, a squared minus ab, plus b squared pattern. So what I need to do is I need to think about what would a be if x cubed is the first term. I guess that would make a just plain x. And then I have to think about what b would be if b cubed were 8. Well, the cube root of 8 is 2, because 2 to the third power is 8. So I'm going to go to my pattern and I'm going to write in x's for the a's and 2's for the b's. So now I have x plus 2, x squared minus 2x plus 4 equals 0. Hey, when I have something that's factored, it's not too difficult to solve the equation. So I can set the first factor, x plus 2, equal to 0, and I can factor x squared minus 2x plus 4 equal to 0. So I know for sure x equals -2. But what about that quadratic? X squared minus 2x plus 4 equals 0. Well, it looks like something that might be factorable. I got to think about a pair of numbers that would multiply to 4 and add to -2. Well, if I'm multiplying to a positive 4, that means both the signs have to be the same. So we're looking at -4 and -1, or -2 and -2. But -4 and -1, that doesn't add to -2. -2 and -2, that doesn't add to -2. So this isn't factorable. So what that means is I'm not going to get real answers. I'm not going to get real number answers. I'm going to have to use the quadratic formula, and I'm going to probably see an I. All right, so let's use the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. And since I already have the equation set equal to 0, I can make a be 1, b is negative 2, and c is positive 4. So now I have negative 2 squared plus or minus, whoops, not negative 2 squared. Getting ahead of myself. Let me erase that and try all over again. Let's just cross it out. How about positive 2 plus or minus the square root of negative 2 squared minus 4, 1, 4, all over 2 times 1. Okay? When we do the quadratic formula, the first thing is we want to make all the discriminant turn to one number, so we can put that in our calculator, and if you do it correctly, you get, negative 12. So that means I'm going to have to deal with an I. So if I break down negative 12, I know I've got my negative 1 and then positive 12. 12 is 2 and 6. 6 is 2 and 3. Pair of 2's will come out. The square root of the negative 1, that makes my I. So I have 2i that comes out with a square root of 3 still inside. And then we'll put all that over 2. All of these 2's will cancel. So now I get 1 plus or minus I root 3. So 3 solutions still. The 3 solutions are negative 2, 1 plus I root 3, and 1 minus I root 3. Now I want to show you the graph of this, just to really hit home the point that not every x-intercept, not every root is going to be visible on the graph. So if you go to your calculator, and I'm going to do the same thing on mine, and you graph the function x cubed plus 8, notice that this curve only hits the x-axis at one spot, at negative 2. And that's the same root we got before when we factored out, and we had the x plus 2 factor. That doesn't mean there's only one root. You just saw in your notes there's 2 others. But that's the only real root. So that's the only one x-intercept for that graph. So that's why we cannot completely depend on a graph to solve these problems. Okay? Let's look at the next one. X cubed plus 8x squared plus 37x plus 50. All right, let's do the same thing. Let's graph that to help us out. X cubed plus 8x squared plus 37x plus 50. Okay, well, I don't see any other x-intercepts except this one. Let's just zoom out and make sure that there's no other places where this graph maybe... Nope, doesn't look like it hits the x-axis anywhere else. Looks like it only hits it at negative 2. So that must mean, when we do our synthetic division, I probably want to use negative 2. So let's set up our factor. 1, 8, 37, 50. And according to the graph, it looks like negative 2 is a root. So let's just confirm that. So we'll drop the 1. 1 times negative 2 adds to 8 to make 6. 6 times negative 2 is negative 12, adds to 25. Yep, that's going to work. So I know that x equals negative 2 is definitely a root. Now, if we want to pull together our depressed polynomial, we started with an x cubed, so we're going to start now with an x squared in the quotient. So x squared plus 6x plus 25 equals 0. And again, as I'm looking at this, it seems like it's something I could factor. But I don't think it's going to factor. I need two numbers that multiply to 25 but add to 6. Well, there's only two pairs that come to mind. 25 and 1, that adds to 26. And 5 and 5, that adds to 10. So I think I'm going to have to use the quadratic formula to get my other two roots. So here we go. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right. So if we want to get our discriminant, we'll do 6 squared is 36 minus 100 is going to be negative 64 all over 2. Rats, if it was positive 64, this would be nice. But it's negative 64, so I need I. Well, if it was 64, it would be 8. But since it's negative 64, it's going to be 8I. And again, notice that the 6, 8, and 2 can all be reduced. And so we can now have negative 3 plus or minus 4I as our other two roots. So there you have it. We still have three answers. There's one real answer, which is negative 2. Then we have negative 3 plus 4I and negative 3 minus 4I. Okay, let's just try one more. This is a really different one. Okay, x to the fourth minus 6x squared minus 27 equals 0. Okay. I'm not going to look at the graph on this one. This one kind of looks like something I could factor. If this was x squared minus 6x minus 27, think about how you'd factor that. Pause the video and try it. Now, hopefully you thought about what's going to multiply to negative 27 and adds to negative 6. And if you play around with some of those pairs, you end up with negative 9 and positive 3. Well, look at the whole point of factoring. It's to unfoil, right? Our first was the x squared. Our outer and our inner was negative 9x and positive 3x, and that becomes negative 6x. And then our last is negative 27, negative 9 times 3. When you see a trinomial, 3 terms, where the two powers of x, the highest power is even, like 4, and the middle term's power is half the first term, so that's where it's 2. You can factor this exactly like we just did off to the side here, except instead of putting x and x, I'm going to put x squared and x squared minus 9 and plus 3. And if you don't trust me, FOIL it. X squared times x squared gets me my x to the fourth. 3x squared minus 9x squared is negative 6x squared. And negative 9 and 3 is negative 27. So yet again, I can factor each of these, or rather I can set each of these factors equal to 0, and I'll solve. Now if I move the 9 over, I don't get that x equals 9. I get x squared equals 9. So I'll take my root. Square root of 9 is 3, but I need two answers, so plus or minus 3. I'll subtract 3 for the second one. I'll take the square root. X equals plus or minus, oh, well, I've got a root 3, but it's a negative root 3. Since 3 is prime, the best I can do is take that negative sign and move it out with the I symbol, and I get I root 3. So there you go. There are 4 answers. 2 of them are real numbers, 3 and negative 3. The other 2 are imaginary, I times the square root of 3, and negative I times the square root of 3. Okay? This video gave you a nice little introduction to solving some more polynomial equations where not every root was a real number. There's a couple examples in the notes that I want you to try on your own that are very similar to these. Try to use some of the techniques that I used in this video. We'll go over them tomorrow. We'll look at a bunch more like this till we get the hang of it. Thank you very much for watching, and I hope you have a great evening.